schooling. In the previous video, we learned about covalent bond. In this video, we learn about lone pair, bond pair, and something called a coordinate covalent bond. So first of all, a lone pair and a bond pair. So if you take ammonia, for example, that is NH3, one electron is shared between hydrogen and nitrogen, one is shared between nitrogen and another hydrogen, and one more is shared between nitrogen and hydrogen. Right, so this only is represented like this. So now it has how many valence electrons this nitrogen have actually? It has 5 valence electrons, right? So 3 are here, other 2 will be here. So here what happens is these 2 are the lone pair and these are the bond pair electrons. So it has one lone pair. This molecule as a whole, you have to take this molecule as a whole. Okay, so it has one lone pair and it has 1, 2, 3 bond pairs. So these are lone and bond pairs. I hope you understood what they are. So now let's take a very common example that is used for explaining coordinate covalent bond. So coordinate covalent bond is nothing but sharing of electrons, but in covalent bond what happens? There is mutual sharing, right? Both of the electrons, both of the atoms, both of them share electrons. There is mutual sharing, both of them contribute. But in the case of coordinate covalent bond, it's a one-sided sharing, meaning only one atom contributes electrons, only one atom shares its electrons. Meanwhile, all that the other electron does is accept those electrons, right? So if you take this reaction, this is the reaction that I was talking about. NH3 plus HCl gives NH4Cl. Okay, so this is a very common example. So what happens is, as we already know, okay, ammonia, nitrogen has 5 valence electrons, hydrogen has 1 valence electron, and these get shared. It has 2 more valence electrons left. These are the lone pair. Alright, so this is one reactant. One thing in a chemical reaction is these two are called reactants and this is called the product. Okay, in the chemical reaction. So this is one reactant. This acts with hydrochloric acid. Hydrochloric acid has hydrogen has 1, chlorine has 7. Okay, so these two, they are shared. Okay, so there are 6 lone pairs and 1 bond pair. Okay, so this is how this hydrochloric acid is. So when these two react, what happens is this gets cut off. Okay, so what happens now? Hydrogen, its atom, it has 1 proton and 0 neutrons, and it has 1 electron. Okay, so when this gets severed, when it's reacting, this one, no, what happens? This gets severed. So now what happens? This also became part of chlorine's atom. So now what happened? This electron is lost. It has 1 proton, that is 1 positive charge. So this becomes H+. In order to fulfill its duplet, it needs 2 more electrons. What happens to chlorine? For chlorine, there are 17 protons, okay, and 18 neutrons. So the first shell has 2, second shell second shell has 8 and the third shell has 7. Okay. But now what happens? Since this bond is severed, this electron of the hydrogen also has gone to chlorine. So now it has 8 electrons. Its octet is complete. So this becomes Cl minus with 1 negative charge. So now when this reacts here, in order to fulfill its duplet, this H plus that I told you now, it needs 2 more electrons. Right? And in this ammonia, one is with this hydrogen, one with this, one with this. There are 2 left. Hydrogen doesn't have anything to lose. It has 0 electrons in its valence shell. So what happens? This nitrogen, it shares its. So here nitrogen acts as the donor and it shares its 2 electrons with hydrogen. Hydrogen is the acceptor here. Okay, so or the receiver. So these two, this coordinate bond is denoted by this coordinate covalent bond. Coordinate covalent bond. So it's denoted by this arrow mark. So here this H plus. These 2 electrons are shared. They are not exactly lost. If I say that I'm giving my hand to my brother, doesn't mean that I'm cutting it off and giving it to him, right? I'm not losing my hand. I'm only giving it to him, like touching my brother's arm, right? So like that, this electron will go and it will occupy this. If this is nitrogen's valence shell, these 2 will go and it will also be part of hydrogen's valence shell now. So what happens? There is one positive charge here and this is Cl minus, right? As I already said, once that bond is severed, it becomes Cl minus. And since there is positive here and negative here, these 2 get attracted and they form NH4Cl. So how is this bond represented? This molecule is represented like this. NH, this is NH3 up till this, and then another hydrogen by coordinate covalent bond is added and this gets attracted to Cl minus. Okay, so this is how a molecule of ammonium chloride is represented. So this is NH4Cl and this is how a coordinate bond works. Okay, so that's all for today's video, friends. I hope you understood the concept well. In the next video, we'll learn about isotopes, isobars, and hopefully the next video or the video after the next one will be the last video for this chapter, and then we'll progress with a different subject. So till the next video, goodbye friends. Don't forget to like, share and subscribe to Interactive Schooling.